Welcome back. Thank you for clicking on today's video. Today we are continuing to work on our discussion of paired data, and we're talking about doing a t-test for paired data, and we're talking about doing that t-test with the Fred method. Well, in the last few videos we dealt with the F, and today we'll be dealing with the R and the E. So remember that R is reviewing conditions, and this data, as we've talked about in previous videos, is similar to what we had when we had one quantitative variable. And we did estimating that population parameter mu in a previous chapter. And when we did that, we learned that for that particular data type, it's appropriate for you to check to be sure that the data is fairly symmetric given the size of the data, and that there are few outliers also given the size or the sample size. So we'll use that same method for this t-test where we check symmetry and outliers. Then remember that the E is executing calculations, and for this, when we're doing a t-test, we are going to be calculating a t-test statistic. That's how it gets its name. And so to calculate that, you would take x bar sub d over s sub d divided by the square root of n. Technically, you're subtracting 0 from that, but it ultimately boils down to just x sub d over what your standard error calculation is. So this is your test statistic. Now, test statistics are generic terms. We've already seen one test statistic that was called a chi-squared. Here, because we have this t-test, we have a t-test statistic. Now, inside of executing the calculations, or inside of the E, we have the test statistic, we have degrees of freedom, and remember that's just n minus 1, and we have finding the p-value. So this is something that's going to be a little bit new, because when we did the hypothesis test for chi-squared, it was always the same order, because a p-value is the probability of getting what you did or something more extreme. Well, the same is true here. We still have the probability of getting what we did or something more extreme, but now it is going to depend on our alternative. So whatever our alternative is, that's going to be the more extreme area, and I will just remind you of some of the alternatives that we've discussed. So here we have 3 options. We have 1, 2, 3, and I'm just going to quickly highlight all of the options. All right, these are the 3 options, and we've actually talked about these. So these would be related to not equal to, greater than, less than. So that's the one in the green, and the orange, and the yellow. And remember, we called this a two-tailed test. This is right, and this is left-tailed. So that's how they get their names, and they're valuable because they tell us the area, which is the highlighted part, which is the p-value that we're interested in. So when we end up finding this with our calculator, the t gives us a location on the curve. So how different, or what kind of difference are we seeing in the sample? When you figure out that location, you will then highlight the curve in one of these 3 ways, depending on your alternative. So then you would go to that t-CDF function, and what it wants from you is a lower bound, an upper bound, and then the degrees of freedom. So when you're finding a p-value, you need degrees of freedom, you need what the alternative is, and you need the test statistic, because that helps you to know what area you're interested in. So the lower bound will always be where the highlighting starts. The upper bound is going to be where the highlighting ends. And then you always need degrees of freedom because it tells you which curve you're dealing with. So in this curve, for example, your lower bound would be your test statistic, because that's where the highlighting starts. And technically, with this curve, it goes up to positive infinity, and the calculator can't really handle positive infinity, so here we would do positive 999. For this curve, your highlighting actually ends at the test statistic, so here, the upper bound would be the test statistic, and here, the lower bound would technically be negative infinity, which will equate to negative 999. And then here, if I were you, I would find both tails and then add them together. So we'll practice that because I'll do an example of this, that, and the left-tailed in future videos. But for right now, this is executing the calculations, and I just want to remind you that the last part of executing calculations is making a decision. And remember, we've said that if you have a small p-value, you make the decision to reject the null, and then we have the decision of a not small p-value, and then we fail to reject the null. And we'll practice that again, but this is review from the last chapter, so if you need to go back and watch those videos. Otherwise, I'll see you in future videos for the D, and then we'll start doing examples. See you there!